Now we are starting with the third part of this chapter, that is separation techniques based on separation techniques only, part 2. Now in this we are continuing further with the process of separation, that is fractional distillation, and here we are doing actually the process which is used here is for purification of water. In this process you actually see that there is a reservoir from which we are taking water and we have to purify this water. So what we are doing in this process, there is a schematic diagram which is shown here. First of all, there is water stored in a large reservoir and it may contain many organic waste and bacteria. So what we are doing is that we are transferring the waste water which is there, or water in the reservoir better to say, to a sedimentation tank which allow large suspended impurities to settle down. Then we transfer this water to the second compartment, that is the loading tank, where small suspended impurities are removed by dissolving this water in small amounts of alum. Alum is actually salt, a mixed salt, which is actually removing the impurities. Then we transfer this water to filtration tank for removing suspended impurities further, which can be retained within different layers of gravel, sand, coarse gravel, etc. Then we transfer this water for further sterilization. That was the physical removal of impurities. But the impurities which are removed in chlorination tank is by chemical action. That is, we are introducing chlorine in this chlorination tank, which kills the bacteria and viruses present in water and thereby sterilize water. Then we supply this water to cities through pipelines. So this water is both sterilized also and is also free from physical impurities. Next is the separation of components of air, that is by fractional distillation. Before compression, the air is pre-filtered of dust, that is dust is removed, then air is compressed into fluid state, that is either gas or liquid, and during this compression water is condensed out. Then carbon dioxide is allowed to freeze and is removed as dry ice. Then processed air is passed through an integrated cryogenic streams in which part of the air liquefies to form a liquid, that is enriched in oxygen. The remaining gas is rich in nitrogen and is distilled to almost pure nitrogen. The boiling point of argon, 87.3 Kelvin, lies between that of oxygen and nitrogen, hence they are separated by fractional distillation. The separated products are sometimes supplied by pipeline or as they were flask or gas cylinder in small quantities. Now this is the diagrammatic representation. First they have shown the steps by means of a flow chart, and then they have shown the diagrammatic representation of the whole process. So you see there are various compartments for performing different functions, and finally we are able to collect the components of gas and liquid state, and the process involved here is actually fractional distillation only. Now again a quick recap of what you have learned earlier, that is the differences between mixture and compound in terms of composition, properties, and separation techniques, examples and components. Then we have a recap by means of a flow chart, how we can divide matter into pure substance and mixtures. Mixtures are actually impure substances. Pure substances will include element and compounds, and mixtures will include homogeneous and heterogeneous mixtures. And in homogeneous we have true solutions, in heterogeneous we have colloid and suspension. Thank you.